To factor larger degree polynomials, there are many techniques. We will use one of these techniques. We're going to use the fundamental remainder theorem to determine the root and factor out the root using long polynomial division. The fundamental remainder theorem states that if f of x is a polynomial and f of a equals 0, then x minus a is a root of f of x. Before practice factoring larger degree polynomials, we will practice polynomial division. Now, I'm going to make a quick mark about synthetic division. While synthetic division does work when dividing by one root, and there is a generalized technique, we'll only review long division. You can find out more about synthetic division on Wikipedia, but within higher level mathematics, it's typical to simply resort to long polynomial division. With long polynomial division, we consider a function, two polynomials, f of x over g of x. And here, f of x is called the dividend, and g of x is called the divisor. We would like to show that the quotient, we'd like to solve for the quotient q and the remainder r. Our solution will be q plus r of x over g of x. The quotient is how many times g of x appears in f of x. And the remainder is what's left over. So when we do polynomial division, we are going to set up the set up the expression for division. Then we're going to determine how many times A, the leading term of g of x, make up the leading term of f of x, and write this in above the line above f of x. We're going to multiply g of x by our value a and subtract f of x by this amount, giving a new f of x. We repeat this step until g of x no longer divides f of x. The final expression above the long divisor will be our q of x, and the remaining polynomial r of x, or the remaining polynomial will be r of x. So let's look at the following expressions. If I look at x minus 3 dividing, or being our divisor, and 2x cubed plus 3x squared minus 2x plus 1 as our dividend, let's go through this process. We first start by asking, how many times does x go into 2x cubed? Well, this is 2x squared times. This gives us 2x squared minus 6, or 2x cubed minus 6x squared. And when we subtract this, we're going to get 9x squared minus 2x plus 1, because we bring these terms down. Now we ask, how many times does x go into 9x squared? And this is going to be 9x times, giving us 9x squared minus 27x. When we subtract, we're left with 25x plus 1. And how many times does x go into 25x? It goes in 25 times. 25x minus 75. When we subtract this, we're left with 76. Remember, this is our q of x, and this is going to be our r of x. So our expression, 2x cubed plus 3x squared minus 2x plus 1 over x minus 3 is equal to 2x squared plus 9x plus 25 plus 76 over x minus 3. Let's take a look at our next polynomial division. Here our dividend is 2x to the 4 plus 0x cubed plus 0x squared plus or minus 2x plus 1. And our divisor is x squared minus 2x. Now here, x squared goes into 2x to the 4, 2x squared times. You'll notice I'm putting these numbers exactly above where the x's lie. So x squared goes above x squareds, x's would go above x's, constants above constants. And I find this easiest for long polynomial division. This is going to give us 2x to the 4 minus 4x cubed. And when we subtract, we're left with 4x cubed plus 0x squared minus 2x plus 1. And x squared goes into 4x cubed 4x times, giving us 4x cubed minus 8x squared, which when we subtract gives us 8x squared minus 2x plus 1. And x squared goes into 8x squared 8 times. 8x squared minus 16x plus 1, or minus 16x, sorry. And when we subtract, we're left with 14x plus 1. Now, x squared does not go into 14x. So this means that 2x to the 4 plus 2x plus 1 over x squared minus 2x is equal to 2x squared plus 4x plus 8 plus 14x plus 1 over x squared minus 2. And let's complete our final division. 5x squared plus 3x plus 1 divided by 2x minus 3. Well, here we're going to have some fractions. 2x goes into 5x squared, 5 over 2x times. This gives us 5x squared minus 15 over 2x. Now, when we subtract off this expression, we get 3x plus 15 over 2x, which is going to be 21x over 2 plus 1. Now, 2x goes into 21x over 2, 21 over 4 times. So this gives us 21 over 2x minus 63 over 4, which when we subtract gives us a total of 67 over 4. So our division, 5x squared plus 3x plus 1 divided by 2x minus 3 is equal to 5 over 2x plus 21 over 4 plus 67 over 4 divided by 2x minus 3. And one thing to note is that this term here is often written as 67 over 8x minus 12. That 4 will be brought down into the denominator. I encourage you to practice factoring.